Hey everyone! In this video, we're going to look at another property of limits. We're going to look at the limit of a polynomial. Now, we've already taken a look at the limit of a constant, the limit of a identity function. We looked at the limit of a sum, a difference, a product. We've looked at the limit of a power and the limit of a root. And now we're going to take all of those, we're going to put them together, and we're going to use them when we look at the limit of a polynomial. So I think it's important to start off with just a reminder of what a polynomial is. So just to give you an example, so an example of a polynomial would be something like x squared plus 6x plus 9. So a polynomial is some combination of variables with coefficients, and then our operations are addition or subtraction in between these terms. Our exponents are always going to be whole numbers, and the way we normally write it is in descending order like this. Now, if I want to properly define this, the way that we normally write it out, it looks something like this. So we do a sub n times x to the n power. And now the rest of my terms, I'm just going to work my way down. So a sub n minus 1, and now we'll do x minus 1 power. So we're one less than what we were before. So if I compare that to my example, here n would be 2. Well, then 1 less than 2, now this is the first power. And then we just keep going. So then we have a sub n minus 2 times x to the n minus 2. And we work our way all the way down until we get to a constant. So we have a sub 2, x squared, a sub 1, and then x to the first, and then a sub 0, which would be our constant term. So this is the way we normally write it out when we want to define it with some rigor. But if we look at all the operations that are going on in here, everything is pretty basic. So all these a's, these are real numbers. So let me just write that down. So where all the a's, I'm going to write where every a sub I is a real number. So I'm using set notation here. So a sub I is an element of the real numbers. Okay, so all the coefficients are real numbers. And then the operation we have in between is just multiplication. So a coefficient is out in front of the variable and you multiply them together. Then the other piece we have, all these exponents. In a polynomial, all these exponents are going to be non-negative integers, or they're going to be whole numbers. So let's jot that down too. So and n is a whole number. So then the last thing we have is the operation in between these terms, and that's just going to be a combination of either addition or subtraction. So all those operations, we already have properties for the limits dealing with those. So when we look at the limit of a polynomial, we're going to combine all those together, and we end up with a really nice theorem. So let's take a look at that. So our theorem, so the limit of a polynomial, so the limit as x approaches some number c, and I'm going to indicate that this is a polynomial by writing p of x. So this is a function, but p of x, I'm indicating that p of x is a polynomial and it follows all these polynomial rules. Well, the limit as x approaches c of this polynomial is just going to be that function value at c. In other words, all I have to do is substitute in the value of c, and I get my limit. The other reason we know this works is because polynomials are continuous on the real numbers. So we don't have to worry about any undefined values or any discontinuity. So we can just plug in the value of c, and we can get our limit. So let me show you what I mean with an example. So here I have the limit as x approaches 1, and the function I want to look at is 7x to the 5th plus 4x cubed minus 2x squared. So the first thing, this is a polynomial. I have real number coefficients, all my exponents are whole numbers, and we should be able to just plug in our value to find our limit. So plugging in 1, so since x is approaching 1, we'll substitute that in. So 7 times 1 to the 5th plus 4 times 1 cubed minus 2 times 1 squared. So all those 1s are nice and easy to work with. We just end up with 7 plus 4 minus 2. So then this gives us our limit as x approaches 1 of our whole function this is equal to 7 plus 4 is 11 minus 2 is 9. So again, just to reiterate here, with polynomials, we can just substitute in that value for c, and then we can evaluate our limit by simplifying. Now, this isn't always going to work. It works with polynomials, but as soon as we introduce some division and we start dealing with things like rational expressions, there may be discontinuities that we have to worry about. So when you're dealing with polynomials, substitution is definitely a valid method to evaluate the limit. Thanks.